Hi, this is an Executive Black Belt Week 3 supplement and for Straight Line's Executive Black Belt course. Today we're going to talk very briefly about a subject called baselining, and we're going to talk about assessing it from two different points of view. The first is the customer, and second is the internal process point of view. And as we'll find out, this is it's very one of the key things to understanding this is making sure you do take a look at both of those points of view. This is going to be fairly short, so let's get to it. After completing this module, you will be able to explain process stability and process capability, two words that we want to kind of latch onto, in terms of voice of the process and voice of the customer. And you'll be able to put a baseline together for your key output variable, the KOV. Now, I just want to make sure that everybody is on the same page on this one. So here we are talking about, if we're going through the DMAC process, we already kind of have an idea of our process, and we're talking about putting together a baseline. That means measure phase, gang. DM, it's at the bottom of the measure phase. This is the baseline. Okay, I guess I should have circled it after I wrote it. Let's try that again. There we go. Okay, putting together the baseline, which is kind of the end of the measure phase. And what that means is we're looking for our Y variable, our output, right? So if you have a call center variable, or a call center project, it could be your average handle time. If you have move this out of the way here for a moment. If you have a hospital project, it might be discharge time. Discharge time. If you have an IT project, it might be the number of trouble tickets that you have each week, so it could be your defect rate. Okay, and you want to see how that, you want to evaluate that from a customer point of view and from a process point of view. At the end of the project, you're going to want to have some improvement on that. That's the idea. Okay, so let's take a look at that, VOP and VOC. All right, and on the left-hand side, we can think about this in terms of the SIPOC. The P in the SIPOC, the O are the outputs that connect the process to the customer. Okay. On the left-hand side, we've got process, and what we're going to do is we're going to evaluate the process for its stability. Is the process stable over time, or is it erratic? Is it showing a trend? Is it not showing a trend? What is its typical variation? Is it riddled with all sorts of outliers, or is it pretty stable? Those are the questions that we're going to be asking about our process analysis, and for this, we are going to use a tool, a fantastic tool called a control chart. So this is a control chart, as we've now found out, right? Now that we know this is a control chart, basically a time series with red lines on it. Okay, on the right-hand side, we've got our customer voice, and for that, we're going to ask the question: how often do we fail to meet a customer guarantee or a customer performance level that we've said we're going to meet? And that can be internal customer or it could be external customer, either one. Conceptually, all that really is a histogram with a line through it, and we'll count what's on the left and we'll count what's on the right. For example, in this case, we're talking about processing time, how long it takes us to process something. For this, long processing times would not be good. So though if we had a spec of 95 hours, everything above 95 hours would be bad. So we would essentially count up the percentages on the right-hand side, and that would tell us how much percentage is bad. Okay, that's the voice of the process, or that's the voice of the customer. Voice of the process is on the left-hand side. All right, now one question that we want to ask, or that I often want to ask beforehand, ask the question of how do you typically do this? Well, if you're in a typical company, you use something like a dashboard or a scorecard to assess. And the problem with that, as opposed to using the tools that we talked about just a minute ago, the control chart and the essentially a capability chart, but it's really a histogram with a line in it, is that we typically use dashboards, or I should say scorecards. What are some of the typical things we might measure? Might be quality, efficiency, on-time percentage, the amount of work that's outstanding, things like that. You'll have your own specific measurements as well. You might have an actual. Here's what you actually did. Here's what your target was. Okay? Typically, this is what companies do, and then you'll compare your actual with your target. Another thing that you can do a comparison, so that's kind of the context that you look at into, is you're comparing with a target. Another thing that people typically do is they'll compare with the same time last year. Now, the problem with this is that those comparisons don't really provide a very powerful context. You're providing a much more powerful context when you look at it with a control chart and with a capability picture. And here's why. One of the reasons is, basically you start to view everything as either good or bad. It's either red or green. You're either above the target or you're below the target. You're either above where you were last year or you're below last year. And so that's either good or bad. There's no sort of zone of indifference. Well, we're more or less doing the same as what we were last year, or we're more or less on target. There's no context for understanding that. That's number one. Number two is that very often we get conflicting results when we do comparisons that are very weak, and we don't know how to resolve those. For example, for efficiency, it looks like we're 7.8% below target, but hey, we're above where we were last year at this time. So is that good or is that bad? So those are the kind of things that you want to be, that we're trying to overcome. We're trying to provide more powerful context. Now, just for a second, if we go back to slide 79, if we look at the control chart, we're not making a comparison to one data point or to a single target, but we're looking at all the data points in relation to each other. And so we can see essentially exactly how high this point is with relation to all the others. It'd be very different if we had a point that was, say, way, way down here, right? This would really, truly be an outlier. Or maybe a point that was way, way up here. That would truly be an outlier. But this is really the highest one of a bunch that really, it's not that much higher than the others. The other point is that we can easily put numbers like this into context. Yeah, it's higher, but it's basically in the same category. And finally, on the right-hand side, we don't just compare to an average or a single target and say it's all good. Here we're looking at the percentage of times that we really don't meet the spec. And that's very different than saying here we are on average, here's where we stand on average. Very different. Okay, so when we do it two different ways, when we look at voice of process and we look at voice of customer, remember, voice of process is really kind of looking at how stable is our process. So so we'll be able to evaluate that in two different ways. Are we in control? In other words, is it stable? Or are we out of control? Those are the two different ways that we'll look at it. The second side of this is the voice of the customer. For this is capability, how capable we are. And here we're looking at the percentage of times that we do something right. We can either be good, a very low percentage of bad, or we can be bad, a very high percentage of bad. Okay, those are the two different things that we can have. All right, so, oops. All right, so if we take a look at that, then there are four states to this process. If we start at the upper left-hand side, we've got what we call double trouble. And this is, as we'll come back, we'll talk about what the advice is. That means we have a high percentage of bad and we're out of control. What's the recommendations for that? Well, first, you try and get your process into control. That's the first thing you do. The recommendation is the first thing you do is examine all the outliers and get your process into control. Second thing is you work on process capability. Working on process capability and reducing variation is much, much harder than understanding one-off data points and trying to get something into control. So that's just something to keep in mind. All right? So that's a recommendation that if you start there, the idea is that you try and fix the outliers, you get it into control first, and then you're going to be either here, you're either going to be here or you're going to be here. If you're here, you can stop. If you met the goal, you can stop. If you still have a high percentage of things that are bad, then you can continue to try and move it there. All right. The second one that we want to look at is what if we have what we call product trouble. That is, our process is in control, but we have a high percentage that's bad. This is a difficult thing to deal with, but typically this is a great Lean Six Sigma project, because here we're trying to reduce difficult sources of variation. We're trying to standardize certain things that need to be standardized, build policies and procedures to increase consistency, and try and ferret out errors, get to the root cause of several errors. That's a difficult thing to do. All right. If, on the other hand, you start out and you have an out-of-control voice of process, that is, your control chart shows a lot of out-of-control points, the idea is that you have process trouble, but you still have a high percentage that's good. Well, the recommendation here is that you're getting lucky, so you do a little bit of work to get your process in control. So examine those outliers, see if you can do anything about it. If you can, that moves you toward the goal, which is a good process, right? You have something that's stable and something that is very capable of delivering to the customers. So those are the 4 states. Let's take a look at what those look like. Here's our first case. This is what I call double trouble. This is double trouble. Here we have a process that's got a lot of out-of-control points. See that? A lot of out-of-control points and a lot of bad. This is a bad situation. Recommendation is first, deal with these guys. What's happening to really cause these out-of-control points? Keep in mind, these are good out-of-control points, right? We're doing something really well here. These are good. Let's examine them, as opposed to going in and saying, okay, all the data are equal. First step, let's examine those out-of-control points, see if we can get them in. All right, here's what we call process trouble. And here we have a lot of out-of-control points. All right, so our process is erratic, but we have a customer spec that we can essentially drive a truck through. So we're not hurting from it yet, but of course a competitor could come in and offer, you know, if you're in a hospital and your customers aren't complaining about the wait times in the emergency room, if a competitor came in and said, well, they're not complaining here either, but you know, you're meeting the spec of, say, 30 minutes, but we can meet the spec of 10 minutes, well, that would cause you problems. So it's best to kind of ferret out what's causing some of those out-of-control situations. The next state would be product trouble. And again, this is a difficult one. This is a good Lean Six Sigma project very often, because you've got to do something about a lot of the typical variation. This is typical. This isn't special. Special cause, this is common cause, not special cause. Common cause is hard to beat down. Here you've got to figure out, let's get to the root cause of some of these errors. Let's tighten up this process. Those are the things you're going to try and work on. And finally, this is, of course, the goal. The goal is a stable process, right? No out-of-control points, or very few, and a high percentage of good, meeting customer expectations all the time. All right, to put this all together, the steps of baselining are, again, examine the data over time using a control chart. That's VOP. Okay, and then the second thing is we want to examine the VOC from a capability perspective. That's the word we're going to use. And here, essentially, this is going to be a histogram with a line through it. And you'll count on one side, usually the upper, but you have to think about what's good and what's bad, and you'll count the percent bad. Or if you're a glass half full person, you'll count the other side and count percent good. Let's do an example now, and this one is an example with, let's see, an example with the DMV. Okay, so Department of Motor Vehicles, and you can go ahead and do this one. I'm going to go ahead and do it in, I'm going to use Minitab to do this one. And let's go ahead and open this, or I'm going to use Excel Stats. That's the easiest way to do it. We get to see another control chart. Okay, so I've got Excel stats open, and the idea is, in this case, let's read the whole thing. Column A contains waiting times in minutes in line for people at the Department of Motor Vehicles during peak hours. For the last night, so that's the situation. In a team, we had maybe a Lean Six Sigma team that went in. For the last 90 days, they took one measurement, one customer. That's all they did. They measured one person waiting in line at a random time. And it says that the data are put into date order. It says time order, but date order. So they, one on Monday, one on Tuesday, one on Thursday, and so forth. Okay. Now, from customer interviews and discussion, the project sponsors, the specification is that we don't want customers to wait more than 18 minutes during these times. Okay. So that's the situation that we've got. Let's take a look at our Excel spreadsheet, which has disappeared. There we go. All right. So just to emphasize this point, here's our process box. Here we've got wait time in minutes. Okay, that's our KOV, and that is a numerical. That's a num. Okay. I'm just going to call this wait time so that we get everything on the same page here. Okay, so the first thing is let's examine the process. So let's take a look at how that looks over time. Remember, the data are in time order, so we're pretty good with that. Let's make a control chart. I go to Excel Statistics, copy this. Let's go to Excel Statistics, Control, Numerical. I'm going to do, let's put the data in there. Clear the data first. I'm going to copy my data here. Okay, there's all the 90 points. I will put it into here. And there it is. My wait time is in. Let's take a look at how this process looks over time. Here's how the process looks over time. We can see we've got our control chart here, and it's not so bad, not so shabby. It looks like it's more or less in control, doesn't it? So if there are a couple of points that I might be interested in. I might want to check that one out. I might want to check this one out. Okay, just to see if there's something that was really different about this. I may even look at this. Again, this is just a rule of thumb, these red lines, but basically this is a process that's in control. It's stable. It's not clearly going up and down, and it's not riddled with a ton of really erratic points. If we want to fix this, we're going to have to fix it. We're going to have to dig into probably all of this common cause variation, or a lot of it, and really understand that. It won't be enough to really just do these outline points. And that's the lesson of this one. Okay, now let's see how this looks from a stability point of view. Oops, I don't know what happened to our data points there. They disappeared. There we go. All right. Now let's look at it from a capability point of view. And for that, I'm going to do one num. Now, notice that you can do sort of a, this down at the bottom is a kind of a poor control chart, right? We've got the data in time order, but it doesn't have the red lines. And as we found out in our control chart, discussion, it's hard for humans to really draw these lines. We like to see a lot of patterns. So the tendency certainly would be to look at things like, well, what about these 3 points, and what about this one and this one and this one? That's the tendency of most people. So do the control chart, okay? Although, if in doubt, and if in a hurry, at least get one of those things in. It's going to make your life a lot better if you just do the one num. At least you'll see, yeah, it doesn't seem to be any upward or downward trends. All right, let's take a look at our histogram. And keep in mind, what was the spec that we had? The spec that we had was the customers don't want to wait more than 18 minutes in lines during these peak times. So that's the spec that we're working with, is the, see if I can go back to the, to this right here. This was a spec of, we want it to be, less than, oops, there we go. We want it to be less than 18 minutes. That's our spec. Okay, so when we draw our histogram, let's go to the blue histogram right here. When we draw our histogram like this, we'll want to put a line right there, and that'll be 18 minutes. And then, of course, all the stuff above that will be the bad stuff. Okay? All right. All right, let's take a look at that then. Here we are, and remember that the easy way to do this, or the easier way to do this, is to go onto the summaries page, because this particular histogram gives us a lot more flexibility. So I'm going to try and do that. All right, and so now the trick will be, first of all, the trick will be to make it so that 18 exactly appears on here, and I can look and see what's less than 18 and what's greater than 18. Now, you should notice that already, if we look at it, there's 18 right there, right there where my pointer is, and that's not so good. So all this stuff is bad. Already I can tell I have a very high percentage of bad. But if I want, so this is going to be a really good Six Sigma project. I'm going to have to do something. A good chance that, since I'm starting out from such a bad position, I can make some real improvements. Okay, so let's take care of this fairly quickly, or let's, however, get the exact number or something more exact. So let's go ahead and do that. All right. So one way that we can do that is to make sure that we get 18 on there. So notice that it goes from the min, it says, which is 10, to the max, which is 31. 18 is in the middle of that. What if we went from 18 times 2 is 36, right? So I'm going to put 36 there. So now I've got 36 on the top, and if I put 36 on the bottom, if I go from 0 to 36, I've got 18 exactly there. So theoretically, I could simply now click on percentage and show values and just kind of add all those things up, right? I could do that, but I can make it even easier by, instead of having 10 classes, well, what if I made 5 classes? Okay, that didn't work. Well, what if I made 4 classes? Okay, well, that's not doing so bad. And in fact, that works for me. I could go down as low as 2 classes, which would make my life really super simple. But 4 is good enough. Let's go to 2 exactly right now. And I've got, here it says that 27.78% of the time, I don't need that many decimal places, so I'm going to remove some of that. 27.8% of the time, let's make it even easier, 28% of the time I'm less than 18, 72% of the time I'm more than 18. So this is a walloping 72% of the time I don't meet the spec. So again, even to emphasize this, I could even color it in red. Of course, then I guess I have to color this one in blue. I don't know how that happened, but okay. All right, well, maybe I can't do that. There we go. There we go. Oh, yeah. 72. Now I'm really seeing red. 72% of the time I don't meet the spec, and that's bad. That's really pretty bad. I wonder what happens if if I make it different. That's just goofy. Let me put it back to 2. All right. Okay, so to summarize then, in this case, we have a process that is in control but bad. So voice of the customer, or voice of the process, is stable. Voice of the customer, it's not very good. So again, this is a good project to be doing a Lean Six Sigma project on. On slides 86 and 87, there's a summary of all that. And you can see I've done this one with 15. I did it even better with 2. It makes it a little bit easier. Okay, we can improve this one. All right, and here's a summary of it all on one page. Okay, now it's your turn. In your view, what are the key takeaways of what we just covered? What are the questions that you can now answer as a result of this? And how can you support business improvement with this section? Hope you enjoyed this. See you later.